Hi, my name is Dave Habin, and we're going to take a look at static routing with Packet Tracer and how you can use Packet Tracer to help you with troubleshooting. So take a look. On the computer screen, we've got just a very simple layout, two routers that have already been configured, and all the interfaces are already all set on them. As we take a look at this network, we've got it already all pre-configured, all the interfaces are all set, and all the IP addresses have already been allocated, just like you see on this screen. What we're going to take a look at is, on the router, we'll do show IP route, just to see what it knows about. And it says that it knows about the 1 network and the 2 network. So as we take a look at our Packet Tracer map, here we've got the 2 network, and here is the 1 network. If we look at the other router with show IP route, it also has 2 directly connected routes, so just the 2 and just the 3 networks. So what does a static route look like? Well, it's the command that starts off with IP, then route, and then you have to tell it what you're trying to get to, or the prefix. So in this case, if we're on this first router, what it doesn't know about is this 3 network that's up on the second router. So that's our network we need to try to reach, so 192.168.3.0. And then you need to tell it how big it is, or what the subnet mask would be. And that would be 255.255.255.0. Now, the last parameter, you can do it a total of 3 different ways. You can either specify the next hop address. So for this router, we'd be taking a look at the IP address on the other side of that link. That would be our next hop address. So we could put in there 192.168.2.2. So that would tell this first router how to get to the 3 network on the top router. So let's go ahead and paste that in and see if that works. All right, it's been configured. So now if we take a look at show IP route, we see that we've still got our 2 directly connected networks, and now we've got our new static route to the 3 network via the next hop address. Now here's where we can use Packet Tracer to test this out and see whether or not this is working. We'll switch over to simulation mode, and then we're going to edit the filters so it doesn't capture details that we're not really interested in right now. And I'm going to tell it to show all or none, so that way it'll uncheck everything, and then I'm just going to check ICMP because that's all I really want to see. So now we'll try to send a simple ping packet with this button here from this computer up to the top computer. Now, do you think it's going to make it there? We'll find out. Goes up to the switch, then to the router, and since the router knows where to send that traffic, it's going to send it on to the next hop, which will be the other router, up to the switch, up to the computer sees that and will now reply back to the router, and here is where we have a problem, because that router does not know how to reach this .1 network. So we can go onto it and get it configured. So for the top router, the command would be IP route 192.168.1.0. And we want to be able to reach that entire Class C. So we'll specify a Class C mask. And then for this router, its next hop address will be this serial interface, 192.168.2.1. So we'll copy that into the top router and see if that makes it any happier. So now we can restart this simulation, step through the process, it gets up to the router, it hits the PC, back down to the switch, back to the router, and now it is working correctly. So this is a very simple topology. Now we'll take a look at a more advanced network design and see if what it looks like in that scenario. So here is our more advanced topology, and as you can see, we've got a lot more networks on here. So with static routing, you have to tell this router about all the networks that are not directly connected into it. So it has the 1 network directly connected to it and the 2 network. And we've already told it how to reach this 3 network. So that's already been done. But if we wanted to complete out this scenario, we would have to describe the 4 network, the 5 network, 6, and finally 7. And what you'll start to notice if you do that is, at least on this router, all of these are going to be exactly the same path that it's going to be sending all of this traffic. So when you notice that, there's a way that you can speed this up without having to do all of these manual entries. Because imagine if you had to do this for the entire internet and all the different possible networks that are out there, it would be a daunting process. So instead of doing all these different statements, what we're going to use is a default route. So we can get rid of all of these, and our new command is going to be IP route, and then we specify a set of 4 zeros to indicate any IP address, and a subnet mask that indicates any network, all zeros. And then we have to tell it where do you want that to go. In this case, 192.168.2.2 if we're configuring this on router 1. So let's go ahead and copy this and paste that onto the router. So now if we take a look at the routing table, show IP route, we should see that that 3 network, we haven't removed it yet, so it's still in there. So it has that information, and it has our new default route that we've added. And let's see, at that point I'd probably want to stop it. I got some commands I'm going to paste in there to each one of the routers. Get all these all set. Okay, and ready to pick that back up. All right, all these routers have all the static routes on them. So what you'd want to do is try to identify which routers on your network could use a default route instead of specifying each one of these static routes individually. And the best way to do that is to figure out which ones only have one path back to the rest of the network. So router 1 right here is a very good candidate. It's only got one path back to the rest of the network. This router on the end, router 4, is also a very good candidate because it only has one path to go back. One thing that is kind of interesting about this is this 3rd router here could also use a default route, with one exception. You could specify a default route on this router that points it to the next hop address of 192.168.4.1. So let's see what that command would look like. 4.1, and this would be on router number 3. That's our 3rd router here. But if this router receives some traffic destined for the 7 network, which is down here, what it's going to try to do is send it back this direction. So you can make an exception, and you can say IP route 192.168.7.0. And for that entire class C, when it sees traffic for there, it should send it See if you can figure out which interface it should send it to and what the IP address would be. It should be 192.168.6.2 is where it should send that traffic. And how this works is it takes a look at the longest match. This default route is kind of a catch-all. If nothing else has been specified that's more specific, this will catch the traffic and send it on its way up this direction on the network. But since we're giving it a more specific route, or a longest match is another way it's termed, it will say for just that network, we should actually send it back the other direction.